Before we actually get into the last topic, which is Markov processes, we're going to need to talk about what a matrix is and different aspects of matrices. So first off, what is a matrix? So a matrix is going to have rows and columns. It's going to be set up like this. Each element is going to have two subscripts. We'll call them I and J. I tells you the row and J tells you the column. So if I write A11, that's going to be row 1, column 1. If I write A12, that's row 1, column 2, and this can go on forever. I could also write A21, A22, and they keep on going. So a matrix is just set up that way. It has all these different components. The subscripts are I and J, and we say that the row always goes first. There's what's called the identity matrix, which we'll denote by I, and I is always a square matrix, but it's just the matrix that has 1 along the diagonal and then 0 everywhere else. So if you want to look at the 2 by 2 identity, that would be 1, 0, 0, 1. If we look at a 3 by 3, that would be 1, 0, 0, 0, 1, 0, 0, 0, 1. So the identity can take on different sizes, but it's always a square matrix, and it always has 1 along the diagonal, and 0s everywhere else. We can add and subtract matrices, but what we're going to need in this class is multiplication. So the way you multiply two matrices is really two things. First off, if you're looking at a matrix, let's say that we have a 2 by 2 as a 2 by 2 matrix. Remember, we always say that the rows go first. You can only multiply this by something that also has a 2 as the first number. So I could multiply this by 2 rows and 4 columns, like 1, 1, 0, 2, 3, 1, 4, 5, something like that. But if you write out the size of the two matrices, these two values in the middle have to line up, and your result is going to be whatever's on the outside. So a 2 by 4. So it'll have 2 rows and 4 columns. We'll talk in just a second about how you actually multiply. But it's really important that the two numbers in the middle match up, and that whatever the two numbers on the outside are, those are going to be the size of the resulting matrix. So let's do a couple of examples. Let's say that I want to do 1, 2, 0, 1, then times 2, 1, 1, 1. Now the first thing we want to check is, can you actually multiply these? Well, the first one's a 2 by 2, the second one's a 2 by 2. So these two numbers in the middle are the same, which means we can. And our result is going to be a 2 by 2. Okay, so then to figure out these 4 elements, I'm going to look at this first one. That element is in row 1, column 1. So to figure out that element, I'm going to multiply row 1 of my first matrix times column 1 of my second matrix. So if I multiply row 1 by column 1, so 1 times 2 plus 2 times 1. So these are coming from row 1 of my first matrix. These are coming from column 1 in my second matrix. So that gives me a 4. Next, I'm going to look at this element. So that element is row 1, column 2, which means I should multiply row 1 of my first matrix and column 2 of my second matrix. So I'll get 1 times 1 plus 2 times 1. So this 1 and this 2, that's coming from row 1 of my first matrix. This 1 and this 1 are coming from column 2 of my second matrix. For this next one, so now I'm looking at that element's in row 2, column 1. So I'll do row 2, which is 0, and then column 1. So 0 times 2 plus 1 times 1, which gives me 1. And then my last element, that's row 2, column 2. So that's going to be row 2 of my first matrix times column 2 of my second matrix. So 0 times 1 plus 1 times 1. So there is our matrix. I want to do one more of these. Let's do 3, 7 times 2, 2, 1, 1. So just to make sure that we can do this first one is a 1 row by 2 columns. The second one is a 2 row by 2 columns. These two numbers are the same, so that's good. And our resulting matrix is going to be a 1 by 2. So 1 row, 2 columns. To figure out this first element, that element is in row 1, column 1. So I'll be multiplying the first row of my first matrix times the first column of my second matrix. So 3 times 2 plus 7 times 2. So that's 14 plus 6, which is 20. For my other element, that's in row 1 still, but now it's column 2. So I'm going to take row 1 of my first matrix times column 2 of my second matrix. So 3 times 1 plus 7 times 1, which is 10. So those are all the matrix properties that we're going to need in order to do the Markov processes, but kind of practice this multiplication because that's a little bit difficult to understand immediately, but make sure you do before we move on.